Ethiopian Technical University Building Construction I1. Contents: Introduction, General definition of terms, building classifications, classification based on occupancies, classification based on types of construction, components of a building, design and performance requirements, project life cycle of a building, participants in building project, site organization and setting out in a building. 2. Building is an assemblage that is firmly attached to the ground and that provides total or nearly total shelter for machines, processing, equipment, performance of human activities, storage. Building design is the process of providing all information necessary of human possessions, or any combination of these for construction of a building that will meet its owner's requirement and also satisfy public health, welfare, and safety requirement. Building construction is the process of assembling materials to form a building based on the building design. 3. Buildings serve several needs of society, primarily as shelter from weather and as general living space, to provide privacy, to store belongings and to comfortably live and work. The first shelter on Earth constructed by a relatively close ancestor to humans is believed to be built 500,000 years ago by ancestor of an early humans. The initial causes which forced man to look for shelter were fear of wild animals seeking protection against the cold and the heat, seeking shelter against the rain and wind, the desire for a place where everything belonging to the could family be gathered for. The main considerations in architectural design of buildings for all purpose are climate and its effect, people and their requirements, materials for construction and method of construction, regulations and building codes, requirements which must modern house be satisfied for the construction, a plot of land, permission from local authorities, materials for building, skilled laborers for the erection, finance professionals, such as architects and engineers of 5. Buildings can be generally classified in different groups depending upon their occupancy of use or types of construction. Classification based on occupancy: Type 2, non-combustible construction; Type 3, heavy timber construction; Type 4, ordinary construction; Type 5, wood frame construction. Classification based on types of construction: Type 1, fire-resisting construction; residential buildings, educational buildings, assembly buildings, business buildings, mercantile buildings, industrial buildings, institutional buildings, storage buildings, hazardous buildings. 6. 1. Residential buildings include houses occupied by persons where living accommodations are provided. Ex private residences, apartments, dormitories, hotels, etc. 2. Educational buildings include any building used for educational instructions. Ex schools. 3. Assembly buildings include any building where group of people gather for amusement, recreation, social, political, religious and similar purposes. Ex theaters, halls, places of worship, etc. 7. 4. 5. 6. Business buildings. Any building which is used for the transaction of business, for professional service, and for keeping accounts and records for similar purpose. Ex. Garages, barber shops, city halls, courthouses, libraries, etc. Mercantile bulletin buildings. Ny building which is used as shops, stores, market, and for display and sale of merchandise. Ex. Shopping malls. Industrial buildings. Any building or structure in which products or materials of all kinds are fabricated, assembled, ex. Assembly plants. 8-9. 7-8. 9. Institutional buildings. Any building which is used for the purposes such as medical or other treatment or care, or for penal or correctional detention. Ex. Hospitals, prisons, etc. Storage buildings. Any building which is used for storage or sheltering of goods, merchandise, agricultural products, raw materials, etc. Ex. Warehouses. Hazardous buildings. Any building used for storage, handling, manufacturing or processing of highly inflammable, combustible, or explosive materials. Ex. Explosive storage. 9. Buildings are classified on the basis of resistance to fire of the elements of the buildings. Type 1. Fire-resisting construction. Type of construction in which they include the floors, walls, columns combustible. Elements of the building, which and the roof itself, or non. The building is sufficiently fire resistant that it withstands the effect of fire and prevents its spread to other rooms. 10. Type 2. Non-combustible construction. Construction in which the walls, partitions, structural elements, etc. are non-combustible with less fire resistance than Type 1. Type 3. Heavy timber construction. Exterior walls are out of masonry or other non-combustible material. Interior structural members, floors, and roofs are constructed out timber either in solid or laminated forms. Type 4. Ordinary construction. Exterior walls are out of masonry or other non-combustible material. Interior structural members could be partially or wholly out of wood, relatively smaller sections, unlike Type 3. Type 5. Wood frame construction. Type of construction in which practically the whole of the building out of wood or other combustible materials. 11. A building has two basic parts: substructure, superstructure. Substructure is the lower portion of the building, usually located below the ground level, which transmits the loads of the superstructure to the supporting soil. Superstructure is that part of the structure which is above the ground level, and which serves the purpose of its intended use. The basic component of a building include foundation structures, walls, roof structures, doors, windows, and other openings, floor, vertical transportation, building finishes. 12. Substructure, superstructure, and substructure. 13. 3D model. 14. A building structure should satisfy the following basic design and performance requirements. A. The structure should have adequate margin of safety, factor of safety, loading. In addition to that necessary to support its normal B. It must have sufficient stiffness so that its distortion does not offend the eye or reduce the efficiency of the structure for its normal purpose. C. The building should be planned to provide sufficient comfort and convenience to the occupants of the building. 1615. To accommodate the basic functional requirements, a building should satisfy the following requirements in its design and construction works. 1. Strength and stability. Any structural component of a building should be strong enough to carry or support all possible types of loads to which it is likely to be subjected. The loads in a building are commonly superimposed or live loads and wind loads. Classified as dead loads. Dead loads are static loads due to the weight of the respective structural members, i.e., the wall partitions, roofs, column beam, slabs and all other permanent fixtures in the building. 1716. Live loads, also called as superimposed loads, consist of moving or variable loads, due to people or occupants, their furniture, temporary stores, machinery, etc. Wind loads are loads, which can cause uplift on a building and reduce the pressure on the foundation on the windward side and increase pressure on the leeward side. The effect of wind pressure increases with the height of the building. 2. Dimensional stability refers to the resistance to dimensional changes in building materials and structures caused due to elastic and plastic deformations as a result of applied loads, expansion and contraction due to changes in temperature and moisture content. 1817. 3. Comfort and convenience should be satisfied by proper planning of the buildings and its units. Optimum utilization of space, lighting considerations, orientation. 4. Resistance to moisture penetration. The presence of moisture in any building structure deteriorates the material's strength, reduces durability, and could cause partial or total failure of the structure. 5. Fire protection. A building structure should not ignite easily, should provide means of fire escape, should be designed to reduce the spread of fire. 1918. 6. Heat insulation. The building should be designed in such a way to maintain fairly constant temperature of the internal environment independently of the varying climatic conditions externally. 7. Daylight and ventilation. Daylighting is essential to promote the activities carried in the building and to create pleasant inside environment. Ventilation is essential to prevent undue concentration of odors, fumes, dust, etc., and maintain suitable condition the user of the building. 8. Sound insulation. The insulation of noise is a very important requirement for buildings such as hospitals, educational institutions, offices, and residential building located in noisy areas. 2019. 9. Durability. The durability of a building is defined as the time over which a building remains serviceable and depends mainly on type of building materials, environmental exposure, quality of workmanship, degree of maintenance, etc. 10. Security. Due considerations should be given in design and constructing external walls and openings to protect a building against burglary or theft. 11. Economy. The designer must exercise economy at every stage of planning, design, construction, maintenance, and operation. 20. Disposal of facility. Conceptual planning and feasibility study. The project life cycle of a building may be viewed as a process which a building project is implemented from cradle to market demand or perceived needs. Grave. Procurement and construction. Design and engineering through operation and maintenance. Project life cycle of a building. 21. Start up for occupancy. 22. Chapter 1. Site preparation and setting out. 23. 1.1 Site preparation. This aspect considers a. Site layout, b. Site access, c. Storage, d. Plant, e. Site huts, f. Temporary services, g. Fencing. 24. A. Site layout prepared by the contractor as part of their mobilization activities before work on site commences, a crucial part of construction management involving the coordination and movement of large quantities of materials, products, plant, and people. 25. A. Site layout. 26. A. Site layout. 27. Important considerations in site layout. Analyze the contract drawings and documents. Find out restrictions on the use of the site. Analyze the construction methods for the required space to be kept clear. Work out the areas for temporary facilities, accommodation. Create a site layout plan. 28. B. Site access. 1. Actual entrance from the public highway to the site. 2. Access within the site premise. 29. C. Storage. Common storage accommodation / areas at site. Rebar storage / fabrication, timber storage / fabrication, aggregate, cement storage and mixing area, scaffold storage, miscellaneous storage, topsoil / waste disposal area. 30. D. Plants. These are necessary facilities erected on the site depending primarily on the work to be done. Tower crane, mill work for timber fabrication, concrete batching plant, aggregate crushing facility, rebar cutting and bending machine facility. 31. E. Site huts / accommodations. These are temporary buildings erected and used for administrative purposes, storage, workshops, and operatives for the duration of the construction work. Reception and lockup store, staff office, contractor, consultant / client, drying room for operatives, toilets and washing area, storage and plant huts. 32. F. Temporary services. Installation for electricity, water, telephone, and site drainage at the site. G. Fencing provide perimeter protection at the site for the public outside and as well as avoiding theft and pilferage. Usually the standard height for fencing is 2 m. Also a site gate will be provided at the main access. 33. 1.2 Setting out. It is the establishment of marks and lines to determine the position and level of the elements from construction project that serves as reference. 34. Aims of setting out to correct level, size, plan, and position and, to minimization of construction costs. Importance considerations in setting out. 1. Recording and filling information. 2. Care of instruments. 3. Maintaining accuracy, design points. 4. Regular site inspections. 5. Error detection. 6. Communication on site. 35. Before setting out, commence areas/lines must be checked and identified. 1. Boundary line that defines the perimeter of a lot. 1.2.1. 3. Area restricted for setting out. 36. 2. Verge the area of land between the boundary and the street that is owned by the city or local council which is not part of the building site and be protected from damage. 37. 3. Easement part of the lot that has been allocated for a specific purpose where a sewer main or storm water pipeline exists which no part of a building can be built above. 38. 1.2.2 Setting out tools and materials. String line is used to distinguish the dimensions of the building layout. Sledgehammer is used to sink corner stakes or batter boards and posts. Post hole auger is used to dig the holes required to set posts properly in some soils. Hand saw is used to cut batter boards and posts. Hammer is used for building batter boards. Chalk line is used to deposit chalk on the surface in order to make a straight guideline. 39. Conted 30-meter tape, is used for measuring diagonally, usually in a 100-foot length, and for setting out excavation or foundation lines. Tracing tape is used for laying out excavation or foundation lines. Carpenter's level is used to level a surface and to site level lines. It may be used directly on the surface or with a straight edge. 40. Conted line level has a spirit bubble to show levelness. The level is hung from a taut line. Automatic level measures approximate differences in elevation and can establish gradius over limited distances. The landscape level bubble and index linear cement tube nails are used to secure string line to batter boards. Plumb bob is used to locate the corners of the building dimensions. A framing square is used to check the squareness of lines. 41. 1.2.3 Profile boards used for referencing a building and building lines are produced onto the boards. Profile boards should be as close to the ground as possible. If possible, same level and relative to finished floor level. These boards should be set parallel to the building lines and with a reasonable distance to low access for excavation works. 42. Profile boards. 43. Types of profile boards for setting. 44. 1.2.4 Method of setting out. Right angles, 90 degrees, 1. Fixed type builders. Square. 45. Counted 2.3, 4, 5, 3-4-5, method. 46. Counted 3. Isosceles triangle. 47. Setting out procedures. Proceed at the soccer field and bring the necessary materials for demonstration. Practical 1. Setting out. 48.